Hey, we are finally on to the fourth and final chapter 3 review section. So let's pick up on number 17 here. A jet plane travels that many miles in 3 hours, this many miles in 5 hours. The graph of the function is a straight line. What is the slope of this line? One thing you kind of need to know about slope when you're talking about miles and hours and all of this is slope is almost always going to be miles per hour, okay? The speed at which this thing is traveling. The reason this is relevant is because you want to make sure that when you're setting up your rise and run, right, you want to put the miles on top per the hours on bottom, okay? So as you set this up, and I'm just doing that slope formula that's on the formula chart, I'm going to look for where the higher numbers are, which is here. So miles, 2,600 minus 1,560, right? Y2 minus Y1 over X2 minus X1. You've got to make sure when you do the slope formula, pairs match up, 2,600 and 5, 1,560 and 3. This is basically Y1, X1, Y2, X2. Okay, so just keep in mind slope in this situation is miles per hour because it's speed. Then you just do the math pretty quickly. I can actually type this entire thing into the calculator and just say, okay, well, 2,600, oh, I guess I need a fraction. 2,600 minus, sorry, having a little bit of trouble, 1,560 over 5 minus 3. And it tells you right there that the answer is 520. Okay, so it's D. You work it out piece by piece, but you're still going to get 520 over 1. Okay? All right, number 18. We're just creating a graph of this situation where they leave, they stop and pick up people, then they go to a second bus stop and pick up people, and then they take off from Austin to Houston. It might be really tempting. A lot of y'all are going to be suckers, and you're going to go, oh yeah, I go to a stop, and then I go to a stop, and then I go the rest of the way to Houston. This is a situation that you've looked at in science before. The problem is, look at what we're measuring in this graph. We want to look at the speed, okay? So does it make sense that your speed speeds up, then levels off, speeds up, then levels off, then continues to speed up the entire way to Austin or to Houston? No, guys, this is the distance graph, honestly. Your distance, you're getting farther away, and then you stop for a while, and then your distance increases, and then you stop for a while, and then your distance takes off. That is a distance graph. When you look at the speed graph, though, think about it. They are going to take off and then stop and pick up people, and then go and then stop and pick up people. Well, stopping means you have a speed of 0. So I start with a speed of 0. I speed up, I level off, I slow back down, and then I'm stopped while I pick up people. I speed up, I level off, I slow back down, I stop and pick up more people. And then I speed off toward Houston, okay? If you look at the other two, I don't go anywhere, then all of a sudden I go somewhere, then my speed levels off, and then I speed up some more. That's not really what's happening. And then this one, I have a speed of 0. I'm sitting still. I speed up, slow down, sit still, and then take off. This is the only one that shows first bus stop, second bus stop, going the rest of the way. Okay? Number 19. The enrollment here is increasing by 64 students each year. Okay, there's that phrasing again, 64 students each year. That tells me right off the bat that if X is the number of years, my formula better have 64 times X. That knocks out B, and it knocks out D, okay? I'm telling you guys, look for that phrasing of 64 kids every year. Now I've got to figure out, okay, for the next 10 years, 5 years from now, the enrollment will be 1,800. I'm going to go ahead and show you the answer and then explain it backwards. The answer is C. Okay, the sucker answer is A. Y'all see 1,800, you think 1,800 must be in the formula. But let's really think about this. 1,800 is where I'm going to be in 5 years. Well, if I take this formula and I start at 1,800 and then go adding 64s onto it, I'm going to be way past 1800 in 5 years, okay? This one, if I do 64 times the 5 years, I get 20, 30, 32. Then if I add that 320 to where they're claiming I start, the 1480, you're going to see that miraculously, ooh, there's the 1800. So if I plug in 5 years, I get 1800, okay? Number 20, just the slope of the line of best fit. Remember, line of best fit is an eyeball thing. I just kind of sketch and say, well, most of the dots seem to kind of follow that pattern. It's not an exact science, okay? Right off that, without even knowing anything else, I know it has to be a negative. H and J are out. That is not a positive slope. Then I just have to say, okay, well, is it more reasonable that I'm dropping 2 and running 1, dropping 2 and running 1, or that I'm dropping 1 and running 2, rising 1 and running 2? The pattern is clearly F. Look at your scale to be sure, because we did have that other problem where the scale was messed up. This is a nice consistent 10, 20, 30, 40, 10, 20, 30, 40, so you can kind of ignore the scale on there. All right, last question, number 21. We're looking for a direct variation. Remember, direct variation is linear and goes through the origin. So A is linear, goes through the origin, it's safe. B is linear, goes through the origin, it's safe. C is linear, goes through the origin. It can be negative, that's fine. That's direct variation. D is linear, but it doesn't go through the origin. So that is your false one. So direct variation, linear, goes through the origin. All right? That is it for chapter 3. Hope it helped.